Good morning, ladies and gentlemen, participants and guests. Welcome to, we're going to start our, in Machu Picchu, to do our last set of conference, the master conference and roundtable on the mechanisms to increase professional opportunities for engineers. Professional competencies is values in the engineering profession. To start this important conference, I'm going to present our speaker, Dr. Smaine Zeroug of USA. He's the Director of Research and Scientific Advisor of Zeroug Ph.D. a leading company in oil and gas. He has a graduate from in Argel University, MSc in Electrophysics by the University of New York, USA. MBA. And he's acoustic measurements for applications in oil and gas and in this sector of non-destructive assessments. He's an author of 100 papers, and he has 40 applications for patents with 25 granted so far. To start his presentation, I leave Dr. Smaine Zeroug. Welcome, Dr. Zeroug. Thank you for being with us today. The floor is yours.
Thank you. Thank you for the opportunity to share with you some thoughts on this very important topic of how to help the fresh, the young engineers look at the next decade or two and thrive professionally, thrive in their career, thrive also in their society and their communities. The title of the contribution here is referred to as 2040 Horizon and Mechanisms to Increase Professional Opportunities for Engineers. As I started preparing for this talk and reflect on my own experience of almost 30 years doing research, engineering, and also working in operations for my company, I thought perhaps the best way I can help fresh engineers is not so much to give them pointers on what kind of mechanisms, in particular, what kind of opportunities they may have in the next 10, 20, 30 years, but rather share with them what I thought would prepare them to best address the challenges that they're going to face, take advantage and look for opportunities in these challenges and thrive. The presentation that I prepared is somewhat generic to also motivate the panel discussion that is going to follow my presentation. So what I ask myself is what kind of questions may go into the mind of a fresh engineer, someone who just graduated from a university with an engineer's degree, for instance, asking themselves, what kind of opportunities are there in the coming 1 to 2 decades? How can I take advantage of these opportunities? How can I remain professionally competitive? How can I thrive professionally? How can I balance work and personal life? Those are quite important questions. They may also have many other questions in their minds as they start fresh into their life. I thought the answers to these questions are not that easy to provide. And instead of looking at depicting what kind of opportunities in the industry or perhaps in government or in other sectors, perhaps what I can share with them on the basis of my own experience and many of my friends and colleagues, including Julio here, my good friend, where we worked together in the same company, and then I kept up with him as he went on his own. It's really, instead of predicting what the future is going to hold, perhaps it's better actually to prepare oneself for the change that is going to come. There is no question about it that in the next 10, 20, 30 years, all of us, in particular the fresh engineers, are going to see changes happen. That's happened in the past. And the best way is really to embrace that change, look for opportunities in the challenges faced, and prepare well. And also expect to have to continuously learn. Okay? And I'd like to develop these pointers around, if you'd like, a bit what the past has been, what the current trends are shaping up, and share with you one example that myself, my team, the colleagues that I work with, my own company has faced about a number of years ago to illustrate something that we weren't expecting to happen, but we faced. And we faced with, that came to us with a big celerity. And it's something that hit us and we had to adjust and we had to respond and deliver. So I'd like to share that with you as an example, if you'd like, of what could potentially the young engineers may face in their first 5 years, or perhaps in the after that, in the next 5 or 10 years. And then also to motivate and provide some pointers for the panel discussion that is going to happen, is give, if you'd like, my own thoughts on preparing to thrive in one's career. Okay. So I think it's important actually to start with this, and this is not going to be, if you'd like, new or surprising to you. We're all engineers, and we know actually that engineering technology has been driving societal change over the past, one could say 150, perhaps even 200 years. I'm displaying here some key images that provide, if you'd like, what happened with the discovery of energy resources that really powered the world and accelerate the development to transportation, to the construction of, at a large scale, of bridges and cities, to, let me reduce this, to sometimes also, I think, technology that led to perhaps not so valuable for society developments, space exploration, transportation that reduces the distances and the time that it takes us to connect, to things that have shaped also our own home in terms of appliances, computers, but also how we benefited directly through healthcare, right? Now, that impact of the technology we have seen has accelerated significantly over the past 20 years, 10 to 20 years, in ways that have dramatically changed our life, our profession, the working environment, the community we live in, the way we interact. And I'm sure that in this conference, many have touched upon this, that this has accelerated the change we see in society and also in the working place. I'd like actually just to highlight that this is one image that I like, that reminds us actually to be careful in adopting too much and too rapidly some of this technology, in particular for the young generation that may not have the background that we've had, some of us have had actually, and take some distance from the overwhelm that the new technology, in particular mobile technology, has led us into adopting. Okay. But I'd like to highlight that there were, and there is actually increasing certain benefits that are tremendously impacting our society, ourselves. I mean, I'm highlighting here the mapping actually of the genome, the human genome. And speaking of that, and providing an example, if you'd like, of how engineers have made an impact, and are making an impact. Just want to highlight actually a person that lives close to us, Julio and I, and who work actually within the same town. In fact, his company is above our office. This is a person by the name of Nubar Afiyan, who started as a biomedical engineer back in the late 80s. I'm highlighting him because of his impact, his team impact, and also what went on and have been developed around the activities that he led. The training that he had was in biomedical engineering. At the time, nobody saw actually biomedical engineering making the impact that it ended up making. There is a sentence here that he shared in an interview, if you'd like. He said that back in the early 90s or so, they went from this idea of using biomedical engineering skills to work on protein manufacturing and innovate around it, to actually what is now referred to as messenger RNA, so that a patient becomes a manufacturing facility for their own drugs. This person ended up facilitating the start of a large number of companies operating mostly in the life sciences field. One in particular is Moderna, that actually has an office above our office. And I'm just highlighting actually here to highlight the effect of how engineering is making in our life, in particular for what the world and us all have experienced over the past year and a half or so in regard to COVID. This is a tremendous development that is helping us in terms of the vaccine that most of us have actually benefited from, and we see now the positive results. So this is again an example of you engineers have impacted the society in tremendous ways. Okay. Now I'd like to move on just to highlight a list of trends that are ongoing right now, and they're likely to shape the way we work, the way we live in the coming decade or two. And those are trends to keep an eye on for the young engineer, in particular in deciding what sector, what industries, and what skills actually they may want actually to pick up and prepare themselves for. So I have a list here on the left-hand side. I'm not going to go over these lists. They do provide pointers, again, as to what kind of opportunities would arise. What I would suggest is the following, is that if one follows where the money in R&D is going to, in particular from a large number of governments around the world, a large number of regions, then one actually can learn about the trends that are going to happen, the innovations that are going to materialize and would impact not only our professions, but also our careers. I'm showing here a list, if you'd like, of the significant amounts of money that are going into R&D. It's nearly about $2 trillion for the year 2020. This is just the top 10 countries. That is, if you'd like, here a certain distribution of where this money is coming from in terms of continents in particular, highlighting in particular that certain regions of the world are investing heavily. And development will come through that. And if one keeps an eye on where the money is going and looks into the detail, one can learn a lot, actually, whether you are an engineer or a professor in a university, or a researcher, or a president of a division in industry. You can learn a lot about actually what developments will materialize by looking at where the money is going. I'd like to move on now to say that these trends and the sectors that have been highlighted in the previous list are certainly going to introduce changes. But I think we should realize, as young engineers should, that other changes could actually arise that could throw quite an upsetting to perhaps what a person may be thinking of what is going to happen in the future. Some of these changes are often unexpected. COVID-19 that we have lived through and we still are going through is a black swan, so-called the black swan, if you'd like, that nobody to some extent has predicted. And it has changed our lives, the way we work, the way we're going to work, and the way we're going to live, one could think. So this is to highlight actually that changes, whether through technology development that are impacting our society or through other means, are going to happen. And the best way for me, for I think those that have some, if you'd like, some experience in industry, in government, in academia, the best way we can help engineer is really to always highlight that changes has come, and the best way is really to prepare for that change. So I'd like now to share with you a big change that we have faced a number of years ago, and share with you how we went about as engineers working for a research and industrial research and an engineering center for a company that operates in the sector of oil and gas. So this happened in the early 2010s, if you like, 2012, 13, 14. It is still ongoing, and many of you, I'm sure, have discussed this in this 3-day conference. That is, it refers to as the digital transformation, or loosely called the Industry 4.0, in reference to what happened in the past, transformations that have also impacted society. In the oil and gas, the way the digital transformation has impacted the sector is really in making the realization that the most recent development across multiple technologies, whether it's sensors, whether it's high-performance computing through the cloud and edge, whether it's in the data analytics and data science, automation and robotics, or the communication and connectivities, the many advances that have been made can be leveraged actually to improve in a significant way the business performance and gain operational efficiencies. So it's a realization that came about quite quickly in the space of a few years. And most of the big operators, the big service companies in the oil and gas industry, just like in many other industries, started actually scrambling, literally scrambling on how to meet the demands, if you'd like, how to transform their organization, the way they work, to take advantage of this progress made in technology across multiple dimensions. For the oil and gas, it's really improving the way they explore for hydrocarbons, the way we plan the field development, the way we optimize facilities that produce, as well as the way we monitor the effect on the environment. And since actually it is very timely, decommissioning and abandoning certain platforms, offshore platforms, or certain wells or fields on land. So for us and my team in the center where we are, we're experts in measurements and in the use of measurement data to model and to characterize the subsurface and inform those that have to take decisions on how to drill and how to produce effectively, how to drill safely, how to make sure that production over a period of 20, 30 years doesn't affect the environment, and at the end also abandon the fields that would produce from in a safely manner. So, and that meant actually for us is the quest for efficiency and effectiveness meant that we need to leverage the recent development in machine learning and artificial intelligence to automate the way we analyze the data and we interpret it to be the basis for decision taking at all levels of the industry. The challenge that we faced is that our workforce was made and still made of mostly engineers and scientists trained in traditional disciplines. Only few had any advanced background in signal processing and applied math to quickly pick up on machine learning, AI, and deep learning, if you'd like. More importantly, there was hardly any trained in data science. And we lacked the presence, if you'd like, of data engineers. Whoever is using now data science or machine learning requires that a great deal of time and effort is put on preparing the data, right? So we had no one trained in data science and no one trained in as an engineer, if you'd like, to help us in the infrastructure in particular. Something that has evolved to be called, for those experts in the field, full stack engineer, software engineer, that is. That was a big pressure on us to deliver on this digitalization transformation. So in the year 2014, 2015, we had to recognize that a big change was happening around us, and we were asked to deliver on this, to support the rest of the organization in the quest to adopt digital means. And that meant actually to adapt and embrace new tools and start delivering. That is, developing services, developing products to support the business of the company. That meant actually a great deal of management change. How do you go about actually navigating this change, helping your team to start actually gradually embracing new tools, understanding what goes on in this digital transformation, and start being productive as soon as possible? The solution mechanism that we had adopted was to elevate as much as possible the awareness to the ongoing trend around the digital transformation that has impacted pretty much all industries and slowly was moving into the academic world, was moving into governments as they manage organizations and societies. We quickly actually started organizing ourselves and making sure that the workforce that we had, the large number of engineers that didn't have a background in data science or software engineer, started actually picking up those skills, offering free courses online as well as in the premises where we worked, giving constantly seminars and having discussions around what it means actually to bring in these tools of machine learning and AI into the skill set that we already had, and which was successful actually at developing products, except these products did not directly spoke to the efficiency and to the automation and the integration that has become doable with the advent of deep learning, AI, cloud infrastructure. Okay. One thing actually that we ended up doing over the period of 2 to 3 years is what I refer to as tinkering. That is experiencing, practicing on multitude of projects, how to learn machine learning and use it in the problems and challenges that we knew we had to solve within our domain. Often by bringing in students that had some background in data science, particularly computer science students, electrical engineering students with signal processing, and that had some practice of machine learning. We hired a large number of them as interns, student interns, to work with our engineers and our scientists, and kind of that allowed our scientists and our engineers to learn about the new tools and start adopting them. One thing that we also ended up doing at a large scale is engaging and collaborating with academic teams, industry teams that were leading the trend in this digital transformation. The center that I work happens actually to be very close to some of the centers that are leading in this artificial intelligence, whether it's MIT, Massachusetts Institute of Technology, or Harvard. We took advantage of that. And this is just to highlight that academia has a big role to play in helping those in industry to prepare themselves and navigate the change as it happens. Often we see academia at the forefront of research and looking at the latest trend and looking at solutions and explaining what the trend is about and providing the support and the means to help us in industry and others in government organization navigate these change. We also had to align ourselves with what's going on in the rest of our own organization. And that meant actually a great deal of communication around what we were doing, understanding what the rest of the organization was doing, in particular around cloud infrastructure that we had to adopt. So we had constant communication around that. It was, I would say, quite an upheaval. Okay. And we had actually to quickly also, and this is a message for all engineers, quickly demonstrate that we are not only practicing, but also adopting and delivering on the objectives, that is, developing and deploying novel solutions to the business. I just want to share one example that I myself was part of. There was a technical challenge, and what we saw is that the new deep learning tools in particular could afford quite a solution. This had to do very quickly, for those who are technical, on acoustic imaging through steel tubings. These are steel of the thickness of a centimeter or so, two of them. And if I were to explain this, this is a measurement that is supposed to happen in a well of multiple kilometers in depth. And we use acoustics for that to see through the steel tubing that is often used for production, but also to isolate different layers of the earth. So we isolate those producing hydrocarbons from those that have water aquifer or so. The acoustic imaging is expected to see through steel and tell us with an azimuthal resolution whether there is cement, which is expected to be there, or a lack of cement, for instance, liquid or something, or heterogeneities. And in case there are a lack of cement, then the operation would perforate the steel and put in cement there to make sure that one can safely produce from this well or can safely abandon this well. In fact, we developed this technology to help and support the job planning of abandoning wells. Okay. We used existing tools, and that's one key. We leveraged existing tools that were not meant to solve this problem. They were meant actually to do imaging in open hole for those in this field. We use deep learning to an advanced level that allows us actually to crack that imaging and provide azimuthal resolution. What I would say is that our adoption of these new techniques helped us solve a big challenge, a big technical challenge, and provide a novel solution that I'm very happy actually just to share with you that a few days ago it got recognized with a World Oil Organization award rewarding the upstream oil and gas industry leading innovations. It was one of the 10 awards in the industry for this year. So I'm quite proud of my team, if you'd like, that quickly adopted and learned new techniques to solve a particular problem using available measurement technologies. So in retrospect, and what happened in this change? So I think what worked for us is not so much that we forecasted what was coming. I have to say, really, it hit us. In 2013, 14, it hit us. We're glad, actually, to be close to a hub that alerted us to what was going on in industry, what was coming to us. So it wasn't so much that we forecasted what was going. It was actually we recognized the ongoing change and we embraced it and adjusted through continuous learning and change management. Taking advantage of what is available. And this is also for the fresh engineers. There are plenty of online courses to help you almost in any field that you desire to learn and help navigate, if you'd like, through understanding of that field. Increasingly, digital tools are democratized. We took advantage of that. And I think we took advantage of a thriving surrounding. This is just to say that academia has a big role to play in helping engineers in general operating in government or in industry to thrive. The one thing that I share with you is that we were quite successful in having retained the engineers that had traditional disciplines or were trained in traditional disciplines. They now have embraced and have actually practiced enough of this digital means to be called digitally literate. They are thriving in their careers. And more importantly, actually, we retain them and they are ready to take on the next challenge. And I can tell you, perhaps at the panel discussion, that yet again, we are being hit with a new challenge. We are facing a new challenge. So it's not just about digital transformation, it's also how our oil and gas industry is now evolving towards the next chapter, which is the renewables, the reduction in carbon footprint, the sequestration of carbon and monitoring that it stays where we sequester it. So our engineers and our scientists are engaged actually in activities of the sort with a lot of confidence, because we have managed and demonstrated to ourselves that we're capable of embracing change and thrive. Okay. Now I'd like to go quickly actually on perhaps a set of pointers, of attributes, skills that would prepare engineers for a thriving career. And this is to motivate also perhaps the panel discussion that is going to come after my talk. So I'll cut this into two categories. There are skills that as engineers, as scientists, we develop in schools and also through continuous learning. And those, perhaps one could call them hard skills. There are also another category of skills that as an engineer, as a scientist, we develop on the job, soft skills. We acquire on the job and we tune them actually. And those are perhaps may not be as important in the beginning of an engineer's career, professional career, but definitely after, I would say, 5-10 years, they become quite important. And I'd like to address that as well. I'm going to use also something that I went through, which I thought is useful. This is a recent report from McKinsey and Company of 4 authors that are actually located around the world. And they've done a survey of nearly 20,000 people working in industry, academia, and also in governments in 15 countries, asking them, what do you see the skills that citizens in general need to have in the future world of work? And I think citizens, as engineers, we are citizens as well. And I think the literate citizen of the future would also be likely an engineer. So in terms of skills that we develop in schools and through continuous learning, I think it's important to, and this is really addressing the young engineers, it's important to, or those who are in school now, it's important actually to develop a solid foundation in analytical thinking, critical thinking in particular. If I were to give an example, if you are a mechanical engineer, what I mean by an analytical and cognitive perhaps and critical thinking is, as you do solid mechanics, you learn it really in a solid fashion with the applied math and the physics of the phenomena behind solid mechanics. So that's important actually. It stays with you in your professional career and in your life, and that's important. That would not go away, if you'd like, even when you encounter change in your discipline. I would say a second attribute is really the notion of experimenting and tinkering. It's very important. It's difficult actually to get a sense sometimes of how to solve a problem without approaching the problem from different angles. So tinkering is important in life. I'm sure you do that in your own personal life. I think bring that to your professional life. Being organized is important as well. I think I'm going to highlight that teamworking is important, and that can only happen if we are well organized, we develop the organizational skills. Communication, that is, if you'd like, reducing sometimes complexity and what we understand, what we don't understand, what we solve, what we don't solve as we communicate with colleagues is important actually to develop those skills. Those are important. Okay. Now, a key attributes in the next, I would say, decades is to be digitally literate. And that means a lot. And I'm sure, although I have not attended the talks that happened during these 3 days, I'm quite certain that many have highlighted the criticality now of us all as engineers and scientists or members of societies to be digitally literate, understand what we're dealing with in terms of this digital technology, whether it's mobile communication, mobile computing, or particular the algorithms that we use, the AI that we use. One has to really to understand the if you'd like, the potential, the capabilities of AI, and also the limitations and the risk behind it. This is extremely important, and I suppose we'll come back to it during the panel discussion. Now, for skills acquired and tuned on the job, I would say no product, no service, no problem is solved by any single person. It may have happened 200 years ago, 300 years ago, perhaps even before, in the Greek times, during the Renaissance. It doesn't happen anymore now. Solutions innovation happens because we depend on others, people who are as intelligent as we are, as motivated, and they bring in complementarity. So it's key actually to be cognizant of the fact that we need to work with teams, and hence one needs to develop the skills, if you'd like, to have that interpersonal connection with people. We also, in order to deploy our solutions in society and minimize any negative or misunderstanding, negative impact or misunderstanding of the solution, it's important also to work with those in government that are shaping the policies around the introduction of or the embracing of technology in society. And that also requires teamwork. Okay. I think other skills that need to be developed by any engineer that would like to thrive in their career: leadership, that is self-leadership in particular, self-awareness, if you'd like, being entrepreneur in the sense of taking initiatives, recognizing others when they take initiatives, developing the skills to motivate young engineers, to coach and mentor young engineers, to coordinate and take the lead in that coordination and that communication as to the status of what the team is doing, what oneself is doing, what others perhaps are doing, to help discussion with the stakeholders, to help the discussion with those who fund actually the project that we often undertake, and gradually grow actually and take in responsibilities around managing teams, technical teams, and perhaps then divisions, and then perhaps go on and be, if you'd like, a president of a company or a leader in any particular domain. Okay. I would also highlight, and perhaps we touch upon this at the panel discussion, the criticality of understanding, again, going back at what we do as a community of engineers, impact society, and we need to understand and learn as much as possible about previous experiences and prepare ourselves for taking decisions and stand in terms of the impact, the potential impact of what we do, of what we embrace, of what we push towards our families, towards our community in terms of technology solutions. I think it's important to, again, be cognizant of the ethical impact of what we do or what we embrace. I'd like to conclude with the few takeaways here. So again, technology will continue to drive societal change. And you as engineers, and I'm speaking here to the young engineers that are listening to this talk, you will be impacting with what you do. You'll be impacting your community, your surrounding, your family, your society. The trends that I highlighted early on, and I don't want to, I didn't spend too much time because I think it's that list and understanding what is happening and what is shaping up now is accessible to all of you. And so all you have to do is, again, use the internet in a sensible way. These trends are likely to materialize, but possibly with an expected evolution and impact. And that happened in the past. Expect change, and more importantly, actually, look for opportunities as you embrace that change. If you ask yourself, what are the opportunities in the future? My answer here, and I'm sure the answer to many in this audience actually who have similar experiences, is that often the opportunities are in you embracing the challenges and the change. So I like this, if you'd like, this imagery here. Change is the only constant in life. Now, in order to embrace change, you have to prepare yourself and your mind. You have to have the mindset actually to be ready to continuously adapt and learn the new things that hit you. I like this imagery, and There are some people actually who are quite amazing at reducing sometimes what we say in multiple sentences in just one imagery. It says, it is your attitude, not your aptitude, meaning what you're capable of doing, that determines your altitude, meaning how high you're going to grow and evolve in your professional career, I would say also in your personal life as well. However, I just want to say actually that you do need to prepare yourself with a skill set, foundational skill set to navigate that change. And in that regard, I just want to actually perhaps correct this or enhance it by saying it's your attitude, not just your aptitude. You have to have an aptitude. Otherwise, it will be just wishful thinking that you're going to solve problems and thrive in your career. The soft skills that I highlighted are critical to thrive in career and in society. And with that, I'd like to thank you very much for the opportunity to share some of these thoughts with you and for your time.